Welcome back to Digital Dynamo Lab. In today's video, we are going to learn about the prototyping model, a software development approach that focuses on creating a working prototype before the final system is built. A prototype is a preliminary version of the software that demonstrates functionality and design. It allows users and stakeholders to see, test and provide feedback before the final product is developed. By the end of this video, you will understand how the prototyping model works, its phases, when to use it, advantages and disadvantages. Let's dive in. The prototyping model is a software development approach where a prototype is built, tested and refined until an acceptable outcome is achieved. From this prototype, the complete system or product is developed. This model is especially useful when not all project requirements are known in detail at the start. It follows an iterative trial and error process with continuous interaction between developers and users. In short, the prototyping model helps teams visualize the software early, gather feedback and reduce the risk of building the wrong system. The prototyping model is ideal in several scenarios. Unclear or unstable requirements. When the product requirements are not fully understood at the start. Rapidly changing requirements. If the client's needs are evolving quickly, prototypes help accommodate changes. Developing user interfaces. It is excellent for designing interactive and user-friendly interfaces. High technology, software-intensive systems. Useful for systems with complex algorithms or intricate interfaces. Demonstrating technical feasibility. A prototype helps stakeholders see what's possible and evaluate whether the product can be built successfully. Types of prototype models. The first type of prototyping is rapid throwaway prototyping. This technique is useful for exploring ideas quickly and getting early feedback from the customer. In this method, the initial prototype is not necessarily part of the final system. It may be discarded after gathering feedback. Customer feedback helps identify design faults early, ensuring that the final prototype and system are of higher quality. The second type of prototyping is evaluationary prototyping. In this approach, the initial prototype is incrementally refined based on customer feedback until it is finally accepted. Unlike rapid throwaway prototyping, the same prototype is improved over time, saving both time and effort. This method is more efficient because rebuilding a prototype from scratch for each iteration can be frustrating and time consuming for developers. The third type of prototyping is incremental prototyping. In this approach, the final product is broken into smaller pieces and each piece is developed as an individual prototype. Once all the individual prototypes are completed, they are merged into a single final product in the predefined order. This method reduces complexity as the system is divided into smaller, manageable parts and each part is developed and tested simultaneously. It also reduces the time between the start of the project and final delivery. However, there is possibility that some pieces may not fit together perfectly. This can be avoided with careful planning and complete system plotting before prototyping begins. The fourth type of prototyping is extreme prototyping, which is mainly used for web development. It consists of three sequential independent phases. Phase 1, a basic prototype is created with all the existing static pages, usually in HTML format. Phase 2, functional screens are added with simulated data processing using a prototype services layer. Phase 3, all actual services are implemented and integrated with the final prototype. This method makes project cycles faster and more robust, keeping the development team focused on product delivery rather than spending excessive time discovering all possible needs and specifications. In short, extreme prototyping helps deliver web applications quickly and efficiently. Steps of prototype model. Requirement gathering and analysis. Users are interviewed to collect and define the requirements for the software product. Various analysis techniques are applied to this information to understand what the system needs to do. This forms the foundation for building the prototype. The second step is quick decision making. A preliminary design of the prototype is created. This is not the complete system design. It just gives the user a brief idea of how the software will look and function. This helps in getting early feedback before building the full system. The third step is building a prototype. Based on preliminary design, a small working model of the software is created. This prototype allows users and stakeholders to interact with the system, understand its functionality and provide feedback for improvements. The fourth step is user evaluation. The prototype built earlier is presented to the users. Users evaluate the model, identifying strength and weakness, and provide suggestion and feedback to the developers. This step ensures that the product meets users' expectation early in the development process. The fifth step is prototype refinement. Developers use the feedback from users to improve and refine the prototype. This process is repeated multiple times until the user is completely satisfied with the prototype. Iterative refinement ensures a more accurate and user-friendly final system. The sixth and final step is building the final product and maintenance. The final product is developed based on the approved prototype. It is then deployed in the user environment. Routine maintenance is carried out to fix any issues and update the system as needed, ensuring long-term reliability and performance. Let's look at the advantages of the prototyping model. Early visibility for the customer. Users can see partial products early in the development life cycle, which increases satisfaction. Reusability. Developed prototypes can be reused in future larger projects. Flexibility for new requirements. Changes and new requirements can be accommodated easily. Early error detection. Users' active involvement helps identify errors and missing functionalities early. Quick feedback integration. Simplicity. The model is straightforward and does not require highly skilled experts to implement. Now let's look at some disadvantages of prototyping model. Time consuming. Building and refining prototypes can be a slow process. Poor documentation. Frequent changes in requirements often lead to inadequate documentation. Variations in requirements. During user evaluation, there may be too many changing needs, making development harder. Risk of incomplete requirement analysis. Heavy reliance on the prototype can sometimes lead to inadequate understanding of actual requirements. Thank you for watching this video on the prototyping model. If you found it helpful, please like, comment, share and subscribe for more software engineering tutorials. See you in the next video.